Good morning. So I will rapidly present, but you have all the bios in the website. Our panelists this morning for the session Global Operators Viewpoints, Regional Visions of the 5G Network. At first, Mrs. Zhiqin Wang. Zhiqin is Vice President, China Academy of Information and Communication Technology, but she is also now the chair of the IMT 2020 Promotion Group, our partner organization for 5G. Mr. Akira Matsunaga is acting chairman, technical committee of 5GMF, and also represents KDDI as operator in this panel. Then we have Dr. Haesung Park, who is a senior manager, ICT and R&D Center, Network Technology R&D in Center for Access Network Lab at SK Telecom, important operator in South Korea also. And then my colleague Ashok Rao. Ashok is Vice President, Technology Innovation for SES Networks. SES, as a satellite company, is an international company, but is also a board member company of the 5G Infrastructure Association, and he will represent there the Europe point of view. Just some words to position this panel. While the 5G standards process assures ubiquity and interoperability, regional considerations may create different visions of 5G as operators analyze on their side their spectrum portfolio, their 5G use and proper business cases that they want to prioritize, and other technological considerations, local technological considerations surface. Regional innovators discuss the aspects of 5G as prioritized for success in the countries of their region for the benefit of enterprise operators, government, and society. And we will see that the societal needs and challenges are of key importance. So our panelists will explain us what are on their point of view on their region, countries, what are the deliverables for 5G and how it's being fostered for the future. And we will, at first, listen to Mrs. Zhiqin Wang.
Okay, good morning, ladies and gentlemen. It's my pleasure to be here, give the presentation for Vision on 5G Network. So this slide is written by Mr. Yang Fengyi from China Telecom. Fortunately, he cannot attend this meeting, so I just gave the presentation on instead. So this is the target 5G network architecture proposed by China Telecom, I think it's 4 years before. And it's a very flexible three-cloud network architecture based on SD and NFV. And also the network resources can be adaptable to the user cases. So you can see all this architecture can be divided into 3 parts: the control cloud, forwarding cloud, and access cloud. So most of those network control functions is logically centralized in the control cloud, and the forwarding cloud includes the user plan functions. Access cloud includes the multi-rate and MEC functions. So you can see all this network architecture is quite similar right now with the 3GPP 5G new architecture. CityNet 2025 is the network innovation plan for China Telecom. We're facing the time for year 2025. It's a convergent network architecture based on SD and NFV. So you can see 5G network will be the most important part of this architecture. The CityNet 2025 will use the unified orchestrators to coordinate the 5G network and the fixed network and other systems. Also, it includes the unified network capabilities, exposure functions. Some basic considerations for 5G network. So from the 5G application aspect, you can see for ITU already defined 3 scenarios for 5G applications. So we think at the first stage, facing year 2020, EMBB scenarios will be the first priority. For the massive MTC, we can just use the NB-LT MTC, such kind of technologies right now. For URLC, is a very critical scenarios for 5G. So we do think, we hope the URLC standards can be finalized in 3GPP on time, and we can do many exposures, service exposures from now on, since maybe they have many challenges right now. So for the 5G network aspect, we are starting with frequency band as 3.5 gigahertz or 4.9 gigahertz. That means a medium frequency band. Later on will be the millimeter wave. Since right now, I think 4G and 5G network will be coexist for a long time, and the multi-network coordination technologies, for example, the multi-rate and some application awareness policies is very important. So we will explain more detail in the following slides. Resources sharing between mobile and fixed networks, I also think is quite important, especially for MEC scenarios. The last point is power efficiency. Since right now the 5G new equipment, the power absorption of such kind of a 5G equipment is several times, at least 3 times above about 4G equipment. So the complex for the operators is quite huge. So we encourage all the industry right now to solve this problem. Okay. So I just very briefly introduce the mechanisms for multi-network coordination. One is the traffic steering for multi-rate. That means for the traffic steering to different air interface according to service requirements. So we can have mapping between different kind of services to different kind of QS, then to the air interface capabilities. So one way to do the multi-net coordination is for the multi-rate. For example, maybe we can, for the end users, can use the 4G as the anchor network. If the 4G network is in the lower frequency band, so we can have the coordination between 4G, 5G, and Wi-Fi through the most focus for the radio access network. So another way to do the multi-network coordination is the application awareness. So this objective is to study the mechanism to address use cases dealing with policy-driven selected by 4G or 5G but the core network. So this is a work item proposed by China Telecom, China Mobile, and other international companies within 3GPP-SA2. So this work is still going on. So that's some very basic considerations for 5G. Thank you very much.
Thank you very much, Mrs. Zhiqin Wang. And we will have the opportunity to come back with the questions on this quite nice presentation. Now, Dr. Akira Matsunaga. Contribution to society by 5G will be your presentation. Please.
Yeah, thank you, Jean-Pierre, for your kind introduction. And good morning, ladies and gentlemen. My name is not Dr., but Mr. Matsunaga, and I'm one of the acting chairs of 5GMF. So in my presentation today, rather than speaking about the general topic, I would like to focus on one use case and one experiment which we performed using 5G, since it's one of the good examples of 5G to contribute to society by solving social issues in one region, okay? So I would like to talk about the experiment in which 5G was used to control construction machinery remotely, okay? Oh, thank you. Okay.
Panelists help each other.
Yeah, thank you. Good cooperation.
International cooperation.
Yeah. So these are the three areas which KDDI, our company, is going to accomplish by 5G. The first category is to build more convenient and safer and security society by 5G. So resolving 5G issues in the region is one of the most important missions of 5G, we believe. So in my presentation today, I would like to focus on this area. The second area in which we would like to accomplish by 5G is to provide exciting and exhilarating experience. So typical example is entertainment using video communication, AR, and VR technologies. And the third category is the richer and real-time communications. By using 5G, we would like to provide richer and more fidelity to our communications. So I would like to focus on the first category to build convenient, safer, and security society by 5G. Okay. So as an example of one of the social issues in Japan, I would like to explain about the forecast of a construction industry and the shortage of skilled workers in that industry, okay? And in Japan, promotion of work style reform is a big issue, and which Japanese government is now intensively working on in the elderly society. So this figure shows the shortage of skilled workers and the market size of construction industry. And the market size of construction in Japan is about 5,000 billion in 2014, and will remain the same in 10 years, namely in 2025. While the skilled workers in this region is about 3.4 million in the year 2014, while in 2025, that will be decreased to 2.16 million. Therefore, the shortage will amount to some 128 billion. And the report compiled by Japan Federation of Construction Contractors reports that shortage may be filled up by two solutions. One is to improve efficiency, and the other is train new workers. And the first solution, the efficiency improvement, they can compensate 1.35 million. And by training new workers, the 0.9 million will be filled up. And those include more than 0.2 million women. Okay. And these are the areas which 5G can contribute to the society. So I would like to explain what kind of experiment we performed. KDDI and NEC and the overseas corporations used 5G to control remote machinery, control construction machinery from a distance. So several video sequences transmitted from their construction machinery to a remote site where an operator watches that scene and controls those construction machinery. And in our experiment, we used Wi-Fi and 5G to control construction machinery. Actually, remote control of construction machinery is already in use in Japan in many cases, particularly in disaster relief, because in natural disasters, we have an imminent demand to reconstruct the infrastructure very soon. And currently, Wi-Fi is used to control remote the construction machinery, but the Wi-Fi has some disadvantages because the capacity is limited so that the video quality is not sufficient, and the number of controllable devices at one time is limited due to the capacity, and suffers from interference from other radio technologies. Okay? So we compared the time required to stack blocks in following cases: manned maneuver and remote control with a naked eye, and the remote control using Wi-Fi and 5G. And in case of 5G, 4K three-dimensional video as well as 2K video were transmitted from a construction machine to remote control site, while in Wi-Fi, just HD was used because the capacity is limited. And we measured the time required to stack blocks was compared between these two cases. And this is the result of the experiment. As an operator will accustom to the remote control systems, as a number of trials increases, the time required to stack blocks decreases. And if we compare the result between 5G and Wi-Fi, in case of 5G, 35% reduction of required time was observed. Okay? So that is due to high definition video and 3D 4K video, we believe. So this is one of the examples of 5G can contribute to society by solving social issues. And we sincerely hope that this technology will contribute to promote the work style reform, which now we are going to face. So finally, I'm going to show you the video of the experiment. So would you please show the video? Not start? Oh, okay. Oh, no. Not this one. This is for you. Yeah.
No, it's not the same country. Not the same video. Huh?
Oh, yeah, this one.
This
yeah.
is.
Sorry, no narration in English, no subtitles in English.
遠隔操作システムを搭載した無線機と70メートル離れた操作室間を
The construction machine is 70 meters away from the remote control site. And on the construction machine, 4K 3D camera as well as 2K 3 video camera was installed. And these are the blocks used in the experiment. And we measured the time to stack video, to stack the blocks, sorry. Okay, as I told you, the improvement of efficiency was about 35%. Okay. So this concludes my presentation. Thank you.
Thank you very much, Akira, for this nice and demo presentation. Now, Dr. Haesung Park, on behalf of SK Telecom, this time in Korea. So your presentation will be "It's time to make 5G a commercial reality."
Okay, thank you. I'm Haesung Park from SK Telecom. First of all, thank you so much for giving me a good opportunity to share our 5G vision. I will introduce you the SK Telecom's views on 5G. Actually, as you know well, there have been many trial services and trial specification around the world, but you know, the standard specification of a de facto standard body, such as 3GPP, is initially fixed. I mean the non-standalone. And also, in the previous session, you know, the 5G spectrum auctions are underway in some countries. So I'd like to say it's time to make 5G a commercial reality. This slide shows us the SK Telecom's 5G timeline. Actually, we released lots of documents, white paper or guidelines. For example, in 2016, we released the S-scale architecture, including vision on futuristic telco infrastructure. And after that, we conducted lots of 5G trial services using the 5G trial specification. In parallel, we have discussed the 5G commercial specification and the design concept with our partner for preparing 5G commercial services. And also, we formed the 5G Technology Alliance for 3GPP 5G NL specification with the global operator and the network vendor, device vendor, and even chipset manufacturer. So based on those kind of activities, we will launch 5G commercial services in 2019. Okay, I have to talk about the 5G spectrum. You know, we have to consider both above 6 gigahertz and below 6 gigahertz for achieving 5G key capability and requirements. So according to that kind of consensus, our government announced the KICT spectrum plan in 2017. But at that time, our government had a plan for providing 300 megahertz in 3.5 gigahertz and 3 gigahertz bandwidth in 28 gigahertz. But after the in-depth study on interference between mobile communication and adjacent services, so they confirmed the 5G spectrum auction announcement at the beginning of this month. According to that kind of announcement, our government will provide 280 megahertz bandwidth in 3.5 gigahertz, specifically from the 3.42 gigahertz to 3.7 gigahertz. And also in 28 gigahertz, they will provide 2.4 gigahertz, specifically from the 26.5 to 28.9 gigahertz. But our government also consider additional bandwidth in 3.5 gigahertz. So SK Telecom will pursue as a ranked #1 operator in South Korea. We want to get more than 100 megahertz bandwidth in 3.5 gigahertz. Okay, I think you look familiar with that 5G radio looks like. You know, as I mentioned earlier, we have to consider above 6 gigahertz and below 6 gigahertz, and even including the LTA evolution network. The right side figure shows us the several 5G trial activities in SK Telecom. For example, the world's first 3GPP compliant non-standalone infrastructure development and test in December 2017. And also, we are conducting the perfect 5G using the interworking of 28 gigahertz and 3.5 gigahertz and 2.6 gigahertz LTE. And also, we developed with our partner the 5G small form factor 5G tablet for demonstrating 360 virtual reality video call. And we demonstrate the remote control robot using millimeter wave, and also the millimeter wave handover and 3.5 gigahertz radio, and etc. And from the perspective of services, we demonstrated 5G autonomous driving service and 5G connected car. I will, after my presentation, I show some short video clip for the 5G autonomous driving services. The 5G challenges for MNO is about how to balance the investment, user experience, and profitability. I think network flexibility and the data volume handling can improve two things. First one is CAPEX can be saved by methodology used in the RAN planning. For example, ray tracing or the stochastic model, we can use that. And the second thing is OPEX can be reduced by the methodology of RAN optimization. I think the artificial intelligence mechanism to develop the intelligent system which can detect, analyze, and the environment and take appropriate action in RAN optimization will be fertile in 5G era. Okay, that is my last slide. Actually, this slide shows us the artificial intelligence mechanism in 5G networks. Actually, that is kind of several steps. The first one is the data collection and pre-processing. We can use a variety of input data available. It is possible to go far beyond, not the network data. For example, performance measurement or some network counter, and to include the user-centric data and the contents regarding application, and even the external data outside MNO domains. The second phase is knowledge discovery. That phase can be supported by artificial intelligence-based solution that can smartly process input data and extract a knowledge model which represent the network or user behavior in a way that can be directly used for making smart network optimization decisions. And AI solution rely on the machine learning. As you can see, the supervised or unsupervised or reinforcement machine learning can be used for actually the performing the data mining or some extract relevant knowledge model at different level, user level, cell level, or even the cell cluster level. And the main purpose of machine learning is to develop the computer system for that can adapt and run from their experience. The last stage is knowledge exploitation. Actually, that is regarding the sound function, self-organizing network. Self-configuration means the process for determining needs of new network resources and determine the suitable network configuration and parameter thing. And network optimization means a set of process for improving network performance by adjusting network configuration or parameter while network is running. And self-healing means the process associated with the fault management and correction. Those kind of the activation mean we can automatically improve network performance. And also that kind of thing can be implemented by the other options. It means just AI-based solution propose optimal solution to operator and let operator control the parameter manually. But that is coming from the risk management. Anyway, I'd like to say the combination of 5G technology and AI technology will open the new world, I think. Thank you. That's all. And I will show you some short video worker. Oh, okay. That is related to the autonomous driving with 5G. Actually, we demonstrate at the beginning of this year, we constructed the 5G pilot network in Haesung. Actually, we call it the KCT. That is autonomous driving route. And we are, as I mentioned earlier, we deployed the 5G base station. Actually, they are using the 28 gigahertz band with the 800 megahertz bandwidth. And as you can see, that is autonomous driving. I will show you the steering handle after this picture. Maybe next picture. They are sending the driving information, such as the 3D map. As you can see, the 5G base station. Yes, this one is steering is automatically. So we can, using the 5G connectivity infrastructure and technology and 3D map. That is just the optical camera, but we have also combining the radar image as well. But we have to consider another sensor, and that is a control tower in there. Okay, that's all. Thank you for my presentation.
Thank you very much, Dr. Haesung Park, for this also nice presentation and demo. Now, our last panelist, Ashok Rao, Vice President, Technology, SES Networks. Please, Ashok, you will explain 5G IA regional perspectives from SES point of view.
Good morning, ladies and gentlemen. It's a pleasure and an honor to be here with this large collection of diverse representatives from government, industry, operators, vendors, and really the purpose of my talk is to give you a little slice, a little perspective on the role of satellites in 5G. From not just from my company's point of view, but trying to represent the overall satellite industry, and especially the role of our involvement in Europe in pushing and promoting the use of satellite. So a little bit about the company, which you probably don't know much about it. SES is one of the world's largest satellite operators. It's been in business since the 80s, so probably longer than some of the operators in the room. We have 50-plus geostationary satellites and about 16 medium Earth orbit satellites, which essentially cover 99% of the world's population. The difference between GEO and MEO is that the MEO satellites are much closer to the Earth, and so the latency is lower, the path loss is lower, and you can sustain much higher throughputs. We have been innovating in this area for a number of years. The company carries almost 7,000 channels of video. It provides high-speed connectivity services to operators in all kinds of places, whether it's Brazil, the Pacific Islands, Papua New Guinea, Africa, you name it. There's hardly a country on this earth which is not addressed by our satellites. So, in terms of 5G, we have been fortunate enough to have been involved in the European activities right from the start. One of our colleagues is the co-founder and the vice chair of the 5G Infrastructure Association, along with Jean-Pierre here. We have been promoting the role of satellites and trying to promote cooperation between satellites and the terrestrial world in this, as opposed to a kind of combative or and I'll touch on that a little bit more. We've attended 3GPP standards meetings, and we've been met with a lot of support as we've gone there. And the European Commission, who I'm happy to see there are a number of people from the EC here, has been very supportive. We have been involved with one project called SAT5G, which has been funded by the Horizon 2020 project. and other projects from the European Space Agency, and more will be forthcoming. And maybe the next slide would kind of explain where and why and how satellites can fit into this whole big 5G picture. But before I get into that, let me just talk a little bit about the role of satellites in general, since it may not be something that this audience is that familiar with. So satellites have been around since the 60s and were initially used to provide long-distance phone services before the onset of optical cable. There was rapid evolution there. Video started getting carried, and today a lot of video is delivered by satellite. Apart from video, there's connectivity services. So where you don't have fiber or high-quality terrestrial infrastructure, the satellite comes in. The other role, we talk about safety and societal, from a societal perspective. Wherever there are disasters, you have the only means of communication, effective communication, is satellite. We have numerous examples, as recently as Puerto Rico, the disaster in Puerto Rico last year, the disasters in New Orleans with the U.S. perspective, and then of course Philippines, and with the climate change and the kind of hurricanes and storms and earthquakes and all these other things which are happening around the world, this valuable mechanism, the satellite, which can just kind of override and overlay any terrestrial infrastructure, is incredibly important. So I would really request all of you to keep that in mind. It may be a small business, it may be something which is may be perceived to be an irritant to widespread use of spectrum. On the other hand, it's incredibly important for society. The other thing we talk about is the digital divide. There is a growing gap between rural and urban, and often there is no business case for an operator to go and deploy in a rural environment. And in that kind of environment, it's very, very important to think about satellite as it provides a way of connecting lots of people in rural areas to the internet and to society in general. Okay, with that, the next, I have a little introduction to the 5G Infrastructure Association. That is, the 5G-IA it includes both European terrestrial and satellite industries. It's the private sector part of the 5GPP initiative.
4 minutes.
This 5G-IA is really trying to steer the 5GPP research agenda through studies, through trials, and through eventual deployments. We are promoting the radio spectrum. We're looking to make sure that the spectrum is harmonized, and also keeping an eye on the fact that existing users need to be protected as we go along. So where does this satellite fit into the 5G ecosystem? So we have our own 4 use cases. These use cases are actually being used today in a 4G and a 3G environment. So it's really an extension of that. The first use case is providing connectivity to a core network. So if you are in a remote place, if you for example, you may be in a remote place in Africa, you may have really no other international circuits, you may be a landlocked country, or in the Amazon, the satellite can provide high-speed connectivity, multi-gigabits connectivity to the core network. The second I would say the more important application is backhauling. Again, a situation where the gentleman from Brazil talked about coverage. Well, one of the challenges with coverage is, in order to provide the coverage, not only do you need the RAN, but you also need the backhaul capabilities. And in extremely remote environments, that's very difficult. So that's where the satellite comes in. And there is a perception that satellite is low speed. Well, the speeds in the satellite industry are really following Moore's law, or even better. And we have a significant amount of investment from people like Elon Musk, from SoftBank, from other people going into this industry, billions and billions of dollars, And so the satellite, entire satellite ecosystem is getting geared up to support more and more capacity and higher throughputs. The third thing is communication on the move, Wi-Fi on planes. All of you would have encountered that. You know, it's not something that you may not know it's coming through satellite, but that's the only way you can deliver reliable, high-speed internet on board a plane or a ship. And then the final thing is multiplay, where the satellite provides a video along with the connectivity, data connectivity coming in through the 5G network. So this is just giving you an example. It's somewhat of a busy slide, but if I focus on the right side, we're showing you how we have our point of presence going into a gateway, which then goes over a satellite, comes down to a customer edge terminal, and then the customer edge terminal essentially feeds the 5G RAN, where you may have multi-access edge computing, mobile edge computing, and other things at the RAN. And so the low latency applications run off the MEC, and the slightly higher or latency tolerant applications run over satellite. What we're also showing is the other layers in the slide, which which we are familiar with, which are coming along with the 5G, the various applications, and then the SDN, the service orchestration, and other pieces which will put this all together. On the left side, we show all the activities we're involved with on the satellite side. Between the 5G, SAT 5G project, the ESA project, HATIS-5 project, the 5G PP, and NHC. All right. So the last slide here, if I can take 10, 15 seconds more, is I'm sure, Jean-Pierre, you would like me to continue for 15 seconds. But the 5G Infrastructure Association is really representing the European views here, and they're involved in really very, very important activities here. We have these 3 spectrum bands that we're focused on, the 700 megahertz, 3.4 gigahertz, and the 24 gigahertz band. There are a number of demonstrations and trials happening. We expect also some service launches happening in the UK actually next year, but we're getting very close to it. Europe is a little behind, I would say, the US and Asia in terms of adopting 5G, because the operators are obviously looking at the business case. But there is a huge push, I think, from the government, from agencies, and from industry. As you know, the number of vendors in Europe who produce equipment, a number of satellite operators, a number of very big mobile operators also. So I think Europe has a good plan. It'll do it in a measured fashion, and it's also going to try to include other stakeholders in this process. And in the end, that would be a good result. Okay, thank you very much.
Thank you to all our panelists. We have not much time, but we'll ask some questions. Mrs. Wang, on China side, what is the 5G network and service position in China? We saw in your presentation an aspect with virtualization, so could you widen a bit with this position, 5G networks and service position in China?
Okay. Thank you for the questions. I think that's a very tough questions. And so I maybe just share some opinion from personally. I think 5G is extended from the mobile internet to mobile Internet of Things. So the mobile internet applications, since the business model is more mature, so it will be commercially deployed in the first phases with maybe higher priority. You see right now for the video services, already I think it's over 65% for the data traffic, the worldwide. So I think the video services will have 4K and 8K, yeah, and also HD. So especially I think for the video service can be integrated with the VR and the AR technologies. And I think that kind of services will be get end user performance get improved. And also, I think AR, VR, just like internet, they can add it to different kind of vertical industrials, like intelligent medical treatment. So we can do the remote operations. So in that case, it can extend the 5G applications scope in some extent. For the mobile Internet of Things is a new area. So we think from the time schedule, maybe they need 2 or 3 years for cultivate. And some big market like Internet of Vehicle and Internet of Industrials. But anyway, they may have many challenges. So as it explained by Mr. Wen this morning, the challenges may be more bigger than the 5G industrial itself. So for the 5G industrial should work together with all these vertical industrials to define what is the really the application scenarios, what the technical and the product solutions, also to explore the business model, and even the government policies. So we hope the 5G industrial can really work together with all these vertical industrials to construct the new industrial application ecosystems. Thank you.
Thank you very much, Zhiqin, for this view. Akira, on Japan and KDDI's side, we saw in your presentation a quite illustrative example of how 5G can improve efficiency of controlling construction machinery. More generally speaking, what is the primary role of 5G in your country that you see?
Oh, yeah. Yeah, thank you, Jean-Pierre, for your kind question. So as I presented, 5G will play a key role in a variety of fields, including entertainment, communication, and social issues. And in the field of social issues, for example, as I told you, work style reformation, autonomous driving, educational, environmental issues, so many issues can be solved by 5G. And also, in addition, some applications may be developed with partners, vertical partners. So in my sense, I think the biggest challenge for an operator is to tailor the network to suit the requirement of each service, each individual service. And at the same time, we have to satisfy different requirements of different services. So that is the biggest challenge as an operator, and also the mission to provide 5G. Thank you.
Thanks a lot. And we see the importance of these societal challenges with 5G. Haesung, for Korea and SK Telecom point of view, what are the main differences you see of 5G compared with 4G exactly, and what would be the killer application or applications?
Okay, I have to say, the mobile communication were mainly used for mobile phone call service a decade ago, but mobile communication have been changed to infrastructure for delivering lots of contents using the LTE network and smartphone spreading. But so our customer have enjoyed lots of contents with the faster network. So I can say the LTE changes people's lifestyle. But in 5G, we believe not only customer experience enhancement, but also massive IoT and mission-critical IoT are key values from the perspective of the operator and the customer. So, because the B2C market has been saturated already, so we have to need some new business model or possibility from the 5G connectivity. So we have to targeting the not only B2C, but also B2B market. So I think just the 5G, not only the lifestyle changes, but also the society changes. As actually in the previous session, some guy mentioned before. So I think 5G make everything changes. It's kind of so many guys talking about the 5G is the engine of the fourth industrial revolution. So I believe that is right. So I think 5G can change the whole society. And the other question is killer application. The service and infrastructure technology is kind of the chicken and egg dilemma. So I think we have to develop and deliver the 5G services and 5G infrastructure technology in parallel. So that is common sense, but I think I have some given example for killer application. As shown the short video clip, I think the 5G connected car or some 5G autonomous driving is a key value. The 5G can be the main key capability or key main requirement of 5G can be classified into eMBB or URLLC or MMTC. But I think URLLC, I mean the ultra reliable and low latency communication thing is the most important part. Basically, if you're considering the autonomous driving, actually at this moment the autonomous driving car is installed the whole unit. For example, the steering unit and processing unit and even sensor. If you're using just the general purpose, the IT infrastructure, I mean the cloud server, etc., as a processing unit, it means in the car, just the sensor and the steering unit is just let it, and the processing unit go to the general purpose, I mean cloud server thing. It means the sensor capturing the environment, the raw data, and transmitting to the cloud server using the 5G uplink, and the controlled data transmitting by the 5G downlink case, we can reduce the 5G, the autonomous driving car cost and weight. So I think that is one of a good example for we have to pursuing 5G connectivity. That is, I think, killer application.
Thank you very much for this visionary response. Ashok, last question on my side to the panel on behalf of SES and Europe. We have a different case compared with 3G, 4G, is that in Europe, 5G-A, 5G PPP bring for the first time together the satellite and terrestrial stakeholders. So instead of perhaps in the past fighting for spectrum and so on, we are partnering now. So what benefits do you see for this, and is it a model that could be replicated elsewhere?
Yes, I think the benefits were actually summarized in that slide that I had, which showed that actually satellite does penetrate into many parts of your life. It's just that it's kind of part of the infrastructure, and you don't realize it, whether it's video, whether you're flying, whether there's a crisis going on. whether there's a military action. All these things are the satellite is underpinning. And I think Europe, with its kind of a very collaborative process, where it's also, I think, trying to avoid the problem of building it and they shall come. It's trying to take a more holistic approach that if this is a transformational thing, then we've got to get the industry involved, we've got to get the verticals involved, we've got to get various other infrastructure providers involved, so that the net result is something which can really make a difference to society. I think that just shows the largeness of the vision from the European side. It's also a very quote-unquote European way of doing things, where it's a collaborative way. It's not just my way and or the highway. So to kind of reuse a old expression. And I think the model will work. There are densely populated places like in Asia where it may not be that necessary. In Korea or maybe in Japan, it's not that. But I would see in large parts of the world like Brazil, countries like India and elsewhere, where there is a huge populace which is not capable of getting the benefits of this transformation, that you have to make sure there is a communication mechanism which can provide those kind of benefits to that part of the society. It's really very important.
Thank you very much, Ashok. We have not much time, but we could take one or two questions from the audience to our panelists with their diverse regional visions for 5G, killer apps. Has everything been said? Or yes, please.
A question here.
So yes, please.
Yeah, Ahmed Hayali from Huawei. I have a question, as a general question, probably for any one of the panelists could answer. So today or in the past, we are working on machine-to-machine, but I would say small-scale machine-to-machine connections because of the bandwidth and technology. But in the 5G, we will have massive connections that the speakers mentioned earlier, and that's through NB-IoT or LTE-M. So my question is, how, from carrier perspective, efficiently monetize these types of traffic? Should we keep the existing charging policy, or there should be a new strategy to monetize these types of traffics?
Thank you. So it's a business model question. Perhaps one of our operators could, from KDDI or SK Telecom, on this monetizing business model question, or new models, new revenue models. So please, Haesung.
I think that is very tricky and difficult question, I think. But, we already launched I can say the IoT, the specific network already. We deployed the LoRa network, and also we deployed the NB-IoT using the LTE case, Cat-M1 or etc. But at this moment, that is amount of business is not quite larger than the B2C market. But I think, as I mentioned earlier, it's kind of 5G is underlining infrastructure for society. So if you consider the number of machines, in that case, we can increase some revenue from that kind of market. But there is kind of uncertainty, I know, but we have to consider, as I mentioned earlier, we have to pursuing not only B2C, but also B2B markets, so we have to make some monetizing that kind of, the machine-to-machine communication thing. That is my question. That is my answer.
Thank you, Haesung. We had another, thanks a lot. We had another question. Yes, please.
It's a very simple question. Bernie Koo from AT&T Labs. I heard a lot of innovation and also the robustness, connectivity issue of the 5G. I just want to address one important issue that all of us will be facing in the future. The baby boomer mostly are retiring now, actually aging now. You know, for Japan, I know that there are more people living longer than before. You know, seeing as an Asia country like China and also Korea too. I want to focus one problem is, can 5G build any killer application to save people's life? For example, if an elder have a cardiac arrest on the street, can we have any people to car? We talk about B2B and B2C. I'm not talking about person to car, you know, connectivity. Would any nearby car be fast enough to save a person? Or any people in a senior home can receive a fast alert to save his or her life? Very simple question.
So who would like to respond rapidly? Akira, perhaps? I think it's... Could you just summarize the last part of your question? You save lives.
Well, I just say one simple, maybe let me make it simple. Can 5G save life?
Yeah, save
How?
lives. Exactly. Save lives.
Save lives.
Say yes.
Can I ask, perhaps you want to talk with the gentleman from AT&T Labs, and because we can start our next keynote, and we will thank everyone for participating on the panel.